Another session on the Matlab. Today we are going to discuss about the introduction to the Matlab and applications in the vibration problems. Matlab is a program for doing the numerical computation, or the programming language usually used for doing a numerical computation. So it was originally designed for solving these linear algebraic type problems using the matrix. It has been owned by the Matrix Laboratory. Matlab has expanded into the many things. Actually, the major advantage with the Matlab is it is having a lot of built-in functions. So due to this one way, the disadvantage is it's having a lot of memory, and it consumes a lot of space in the any system if you install. And there is a various toolboxes are available. The toolbox is nothing but a set of commands which are related to a particular domain. So they will that you can choose it. So the toolbox will contain all the set of commands related to a particular topic. That is for signal processing, data analysis, optimization, and control systems problems. So like this way, there is a lot many fuzzy logics, neural network. So like this way, many control toolboxes are available. And these due to that also this takes a lot of memory. And then one more thing, these built-in functions or particular toolboxes you can choose by yourself. And in addition to these, there is a common commands which are available as a normal working for a Matlab. So those things we'll discuss. Where that list itself is a very lot many things like general mathematical problems like ordinary differential equations, and then partial differential equations, algebra. So like this way, and even the trigonometry. All these things are already inbuilt in that. So for that, no need to get the special toolboxes for that. Only available normal installation itself is enough. And those who want to work with the other kind of things like optimization, decoding, then they can use the toolbox, optimization toolbox. And somebody wants to use the control system toolbox, then they can install this control system toolboxes. If you want to Simulink, and then Simulink can be done. Now there is a Simulink and Matlab, and Simulink is came as a now 2020A version is having a combination. So like this way, every year there is updating their software also. Now with the present 2020A is available, and B is also there. I think that is under trial. So now a brief introduction, and maybe some may have a doubt that okay, then what the difference between these matrix, I'm sorry, Matlab, and then our CAD analysis softwares. There actually in the MATLAB, that simulation part, we can't see anything, but whereas numerical analytical ability is very much high. So that's why the MATLAB simulation is also called as the numerical simulation. So whatever analytically we are deriving these equations are there, all those equations we can solve easily by using MATLAB. So these MATLAB will take only the analytical data into the consideration, and according to these analytical data, it will evaluate or the simulate it. And whereas the CAD simulation softwares, it will take the data as well as there is a predefined data are available for each material. So according to that predefined material characteristics only, it will work. And whereas here, these predefinitions and all everything you can give as an input the MATLAB. So that's why it's called as some analytical results. So we can say this MATLAB is nothing but a analytical results. So it is just simply reducing the human effort. And whereas this simulation softwares, you can see the particular steels, how they are behaving, and how the simulation is happening, any fracture is happening there and all. So these things are where you can see very clearly. And these also according to the predefined data, not as only the commands were used there, but they were a material characteristics also embedded in that particular software. So that's why each software is different. Atoms are different from the, again, from the ANSYS, and then KTI is different from there. So because each software is having its own built-in uh, functions as well as the built-in characteristics. So that is the small difference between the normal CAD simulation software and the MATLAB numerical simulation. So here the burden more responsibility is there from the user. So the user need to define each and every line properly, and then only the result will come. Even let us say you forgot only one small bracket, that's enough. The program will be executed. So those problems will be there with the matrix in MATLAB, because these are like only analytical software where if you write properly and then you execute it, then only it will be executed. So if you put a one small value wrong, then your results also will come wrong. But here, the syntax, if you give a wrong syntax, then obviously the program won't be executed. So that procedure is called the debugging of a MATLAB programs. So why I'm saying this debugging is an important factor. Like once you are talking about a smart materials and the composite things, so the composite materials and the composite structures which are developed as a beam, plate. So these data needs a longer course, and where you need to build a very the ABD matrix itself on the strains and deformations or the displacements, and then finding these energies, and after that solving that one and finding these mass matrix and stiffness matrix, and again substituting in the finite element formulations and solving according to the finite element formulation, and then getting the value in terms of the finite element, and then combining all the elements into a one, and after that getting a final stiffness and the mass matrix, and that matrix substitution in a program, and then evaluating natural frequencies and the loss factors for a various conditions, and by changing various boundary conditions as well as the by way changing the various theories. So these things, a lot of lines will be available, or a lot of lines will be there. So those lines, for each line you have to be carefully you have to write. Otherwise, if you um, forgot about some small syntax, so that itself is a will cause a difficulty for you. So it will take a lot of time to again to debug that program. But so here the result whatever you can get from the MATLAB is a very reliable results. So that's what I can say. So with this the small introduction and the perspective of how to apply for the composites. So when you first open this MATLAB, notice the command window is where you will give the MATLAB its input and view its output. So the workspace shows you all of your current working variable and other objects. The history shows you all commands used in the command window. Then it is a editor. Normally, while starting, the editor will be associated with all these things. But next, normally the editor will be separated from us. To open the editor with a new or the old M files using the common open called the file name. You can use that file name there. So this is what how the MATLAB command window, and it is actually an older version, but the appearance is the same. Now also it's appearing in the same manner, only that these tabs and all will be a little bit modified. So this is a command window where you can check the display of the all the output. So here we can see the display, and then there is a workspace. So from where you are using these work and all, it will show. And this is the current command history. So what are the commands you already used here? So those command history will be displayed here. So here the current directory also there, otherwise the workspace will be there. Also both will be available here. So current directory, and this is one of the workspace. So this is the workspace actually now they are using. Then we can use the current directory where the file names will be available. Files will be appearing. And there is some useful comments. What if you give these one a list of m files in the current directory it will show, and dir means what is the current directory. So that list will be shown to you. And type test, display the test.m command window, and this is a delete test. This will delete the test.m. So cd is the change directory. This pwd means the current show current directory. And which test, the display the directory path to close set test.m. So who the list known a known variable. So the host, the list known variable plus the size also it will be showing. So this clear and clc will be using very often. So clear will clear the workspace. So whatever in the left space is there, that one will be cleared. But where the clc, this will clear the command window. So by using these CLC, we can normally once we run some program, there is a lot of data will be available in the command window. So to clear that one, normally we put the CLC. And whereas this workspace, if you want to just clear all the workspaces, so there is various files you opened and then some commands already executed, what memory has been allocated for that, what type of which sort of the class is that, and all these details will be deleted or the erased from the RAM memory. So that's why this clear and CLC will be used. And normally one more thing also we can use the clear all. So maybe if you do multiple times the coding and then from a long time, now in that case it will clear all. So that also can be used. Clear and space all, ALL all, small letters. And how these Matlab take any one single name. Normally, this is very important for any software. What type of input is it? So, what is the default input for anything? Like you can check. So, it will majorly decide how much we can able to give as an input to a particular variable. So the variable is one, the name, or for that we can assign certain values. So that is called as a variable. So normally you can say like A, B, C, or otherwise you can give your own name, and all these things are also yeah names, and these names normally it will take this as a an 8 double array. So always every time the MATLAB will take each variable or each input as a one array. So these are also 8 double array. So the memory allocated for that is also very high. So that's the one more advantage where the MATLAB is suitable for problem solving for many complicated problems. So the grand total is 3 elements using the 24 bytes memory. So each time it will take a 8-byte memory, and it is a double class, double array. So one more thing is the delete variables from the workspace, and we can use that clear AB, then it will delete A and B from the workspace. And whose is another one, the clear all, delete all the variables which are connected here. So those things will be deleted. So the MATLAB treats all the variables as a matrix. then it note down this as a double array. So that's why all the matrices, all the inputs as a matrix. There is one more vectors also there, and it will contain the vectors are the special forms of the matrices and contain only one row or the one column. So these are called as normally vectors, and scalars are the matrices with only one row and one column. So that means even if you give a one scalar value, a scalar value, but even that value also will be treated as a matrix, but in the form of a having only one column, one row. And even vector also in the same way, maybe one row or one column is there. Maybe the let us say one row, then maybe columns are more, or one column, then maybe rows may be more than one. So like that way, the MATLAB and the matrices are the interrelated to each other. Then there is a variable names. Yeah, it is a very case sensitive. Definitely, the name called the capital letter and the small letter both are different. Then variable names can contain up to 63 characters. So you can give like a 63 characters. The memory is also high, 8-byte memory is high. So compared with the anyone, the one can use this name length max command. So what is the maximum length of the we can use of the name length max we can. Then variable names must start with a letter followed by a letters, digits, and underscore. So normally in the another cases or another programs, so these digits won't be allowed, but whereas in the MATLAB allows even digits also as a variable names. The underscore and letters are very common in the C language and Python, C++. So it's the letters and underscores are allowed, whereas digits is allowed only in the MATLAB. And MATLAB variables are defined by the assignments. So what you are assigned, because no need to declare it previously, but in advance, like there also you can give it. That is a define scalar variables. Like here, you can give the example 1. So x equal to 1. So it's defined a scalar variable. But even for the x, there is a 8-byte memory is being allocated. So these x is also having a 8-byte memory. This contain 8-byte memory. And even y is a row vector. Only one row, one row and the 3 columns. So these also has been allocated a 8-byte memory. And z is a column vector because only a 3 rows and only one column. So this colon you can see is semicolon will be indicating for a go to the next line. So you can see this one, 2, 3. So say column vector. So these are different here. Can you able to see this one MATLAB screen, MATLAB command window? Hello? Can you able to see this MATLAB window? Okay. So here let us say A, which is equal to 1, 2, 3. Then obviously this is a 1. Then B, which is equal to. So that is the difference. Once you use this semicolon, then obviously it will become a 1, 2. So that is the column vector. And then you can see the same way 1, 2, 3 will be a in one row, and 4, 5, 6 will be in another row, 7, 8, 9 will be another row. Then whose is the list of the variables defined here. So normally this semicolon to suppress the output. Let us say you put this semicolon at the end of any one command. So then obviously it will suppress. Like you can see here now. So A you put semicolon, there is no output. The same thing you put A, it will come as output. So here only the difference is you not put a semicolon here, and here you put a semicolon. So once you put a semicolon, then there is no results won't be displayed. That is the use of semicolon to suppress the output. So the variables do not have to declare type, because all the variables, whatever you declare, these variables will be allocated with the 8-byte memory, and it is like so not even have to initialize this one. Just assign in it. Just assign in the command window. A is equal to 12 semicolon. So the percentage variable A is assigned. So Matlab, it is called as the Matlab prompt, which you already seen. So Matlab prompt, this is a Matlab prompt, two greater than symbols. Then this prompt will be available normally for all the softwares. And assign. So here the variable A is a variable that we can understand clearly here. So A is a variable, and we are using this equal to. Equal to is an assignment operator. So that means it will assign the variable to a particular other numerical value or some other value, or maybe some other variable also. So here the 12 is a numeral, or the one digit we have allocated for this one. Then after that we are using the semicolon, where it will suppress the output. So what does it do here? A equal to 12. So means A is being allocated with a number 12, and the semicolon will stop its results. If you don't uh, stop its results, or the arrest its output, otherwise we can say this as a 12. So A equal to 12. The same thing, you put 12, then put a semicolon. So there is no output. Like this, how? Yeah, variable. Okay, and then the A multiplication with a, you can see here the star mark. The star mark is nothing but a mathematical operations. So some mathematical operations are available. Already you know that addition, subtraction, multiplication, division. So for multiplication normally we use the star mark. So A already been allocated with 12, and A star 2, that means 24. So like this way the multiplication can be done. Those who are already practicing these Matlab, and already if you installed this one, please practice this one. Command prompt, in the command window itself you can do it. Then B, which is equal to 10, then C, which is equal to A plus B. Then already A is being allocated with a 12, so B is with 10, so C will be 22. So now here we used another mathematical operation called the addition. So the variable will be done. So then A is equal to 5, where B is equal to A by 2. So then there is a division. The forward slash is nothing but a division. So you can see here, after this 2 point, there is a 2.500. So here we need to understand what is the, or how many fractions or the digits after the dot will be there. So there is a default is 4 digits will come, and you can increase this one. And whereas if you see the another sort of the programs where you need to specify whether it is a fraction value or the normal value, but whereas in the MATLAB will take always any some multiplication or the division has happened, obviously it will give in the fraction values also. So then there is a one other symbols also there. This is nothing but the prompt. Put a 3 dots continuously. That means the same line will be continuing in the next. Let us say if you have a more number of lines, then in that case you can use these 3 dots at the end of a that, so that next line will be continuing with that one. So by taking these all the lines, how many lines are there? Then that many lines will be combined as a one single line and will be processed by the MATLAB program. Then comma is a separate statement and the date. The percentage is the start comment which ends at the end of a line. So normally if you want to keep these comment, like many times you'll write many lines, and after the lines or the one some lines you might have given a some important things you may forget. So in that case you can put a comment that okay, this particular a is related with a maybe that matrix or mass matrix or the some stiffness matrix. So like that we have the stiffness matrix, multiplication say stiffness matrix, uh, initiation kind of thing. So what are the comments you need that you can put by using a percentage symbol. And the same thing like maybe if you are writing a code or maybe calculation of a natural frequencies, then in that case you put a percentage, and uh, now onwards there is a calculation of the natural frequency. So like that way you can uh, divide these number of commands in the different lines for your convenience. Maybe if you want to divide, you can divide by using a double percentage symbol. Then that will be separately executed. That's called an execution division. And whereas here, this percentage one percentage symbol, if you keep, means it is for your comment. So that comment can be initiated or the can be started at the initial point or maybe at a midpoint or after the end of a some command. That is also possible, or the some line after that also you can use it. Then you can use here the semicolon to suppress the output that we already seen. Then again we can use these for the row separate in a matrix, so that also we have already seen. Then colon will specify the range. So the range, normally this range will use in the for loop. Then the relational operators, less than and less than or equal to, the greater than or equal to, then equal to. So if you put a one time equal, so then it will be a assignment operator. It is an assignment operator. Normally the equal to you will use for the assignment operator. There is a double equal if you keep rational, also called the comparison operators. And not equal to is a comparison operator. We can use these comparison operators also. And math and the assignment operators. And here we can use this cap symbol. Cap symbol is for the power. And dot power. So dot power means the power is already we have discussed. A MATLAB is a take will consider all the variables as a matrix. So let's say if you keep a normal power, so whatever the matrix rules will be followed, in that way only the power will be taken. But whereas if you put a dot and then put a power operator, then obviously the each element power will be there. So that means each element, it will take it as a element wise, not as a power wise. So let us say a power 2, then that means that multiplication of a and a. But whereas this you put a star power, then in that case only each element, like let's say 2 3 4 5 6 7 8, so each element a 2 to the power of 2 or 2 I mean 2 to the power of 2, 1 to the power of 2, so 4 to the power of 2. So like that way it will be happening. So maybe we can just see one example. A which is equal to 1, 2, 3. So B is A, we kept like A. So this is the B. Let us say C which is equal to A star B. So you can see that it's a normal. So then C which is equal to A dot star B. Then you can see now 1 is multiplied with 2. 2 is multiplied with 3. So like that way each element 1 comma 1 is multiplied with 1 comma 1. So 1 comma 2 is multiplied with 1 comma 2. 2 3. So 2 multiplied with 3 6. So whereas here first row with a first column, A first row with a then summation. So like that way the multiplication matrix multiplication. C means if you not keep a dot, that means the matrix multiplication. The same way matrix power also. Like you can see here again. C which is equal to A power 2. So that means A multiplied with A. C which is equal to A dot power. So that means each element has been, see here A 1 2 3 4 5 6 7 8 9. So 1 2 power 2 4 3 power 3 9. So like this way this is how the difference by using a dot operator or without using a dot operator. So the same way division. If you use the backward slash, then it indicates R, A or B. So now 56 division 8. So 8 by 56. So it is either or 8 or the 56. Then unary addition one and these normally will call this as a only one operation. It's called a normally unary. It's a subtraction and it is a assignment. So like these are the various mathematical as well as the assignment operator. Then MATLAB logical operators. So logical operator will say whether it is logic is correct or not. So not means a logical not, the element wise or the scalar wise, whatever it may be. We can use like either a matrix wise or the scalar wise. Yeah, and we can use the symbol anyone. The R symbol you already seen, either R or I put a backward slash. Double end logical, it is a logical and this two lines, two vertical lines will give as a logical short circuit and. So these are the various logical operators. Then various logical functions are available. XOR A comma B and any X, all X. So is nan means NaN is a none. So there is no value for that. So is infinite. INF means that it's a infinite. So finite returns one at each finite value of the X. So find indices and the values of non-zero elements. So some matrix functions. So zeros, you want to give all the matrix functions is only one particular element. Let us say it is only the zeros. Then in that case, you can put zeros and a parenthesis starts rows, comma, columns. So normally whatever the first element you keep is a rows and next number is So generate random matrix. Once the matrix with 1 in all entries, the identity matrix. You see, ICE means that it will take as an identity matrix. The once the matrix with 1 in all entries. This is the random RAND. RAND means it is a random numbers can be generated. You can check here. Zeros. That is a 2, 3. So then all the elements has become as a zeros. Then RAND. So it will generate the random numbers. So here it will show you some help. So any random number may be generated here. So if you want maybe the type of the thing, that also you can able to. Then once you view only the ones, then identity matrix, the whatever the previous one is there, the same. So sorry, it is a diagonal, off diagonal elements will be a so you can check like this. So 1 1 0 0. Let us say you give like a 2 comma 3. You give like a 1 0 0 0. So it won't miss any identity. Then they're extracting a sub matrices. Like that is a sub matrix matrix R1 Rn. So that means in the rows, how many rows has to be there and what should be its values. So those values you can give like a R1 Rn. Column also you can give like a what is the starting point and the starting end point. Otherwise like a is a portion of the matrix can be extracted and stored in a smaller matrix by specifying the names of the both the matrix and the rows. So already once you allocate or the defined these matrix, then submatrix can be a matrix. So this particular row, maybe we have a 3 comma 3, then maybe you can ask like 1 comma one first element, second element, or otherwise only the third element. Or we can the columns also, maybe we can take 2 or 3 columns. So like that way you can take. And a colon means if you put only one colon here, then that indicates you have a all the columns. And the same here, so we'll the all the rows, only the few columns. And we got this row starting to end, and how much like a if you don't give any division here, let us say we have a some 6 rows, then let us say this matrix is nothing but a 6 comma 6 matrix, 6 comma 6. So in that case R1 2, so let us say this is equal to a 1 4, then maybe 2 6, 2 and the 6, there could be a 2 comma 6. There could be a 2 comma 6, sorry, 2 comma 6. So here it will go like a 1 2 3 4. So that means the in between only a 1 1 only the gap. So like we have 1 2 3 like 4. So let us say you give here 1 colon, then you put a 2 here. Then after 1, it will go to a 1 step, 1, 2 steps. So 1 step, 2 step. So I given a 2. If I don't give anything, it is a 1 step. Then if I give 2, then it will take only a 1, 3. Then after that, 2 steps. So obviously it won't take the 4. Even though the 4 is the maximum limit, it will take only a 1, 3. So only these two elements will be considered here. And the same way, DC is the where there is a division or a gap, how much could be. So these are the gap. So the 1 step, 2 step. If you give 2, that means 2 steps. Let us say you give a 3, and then 3 steps will be considered. The matrix, then colon you already seen, semicolon for the next row in the matrix. Square brackets to define the matrix. Then want to access this A 1, 2. So already we have seen A is equal to 3, 2, 1 and 5, 1, 0, 2, 1, 7. So this is the first row, first column, 1, 1. It is a 1, 2 and 1, 3. And this is a 2, 1, 2, 2, 2, 3. And 3, 1, 3, 2, 3, 3. So here let us say A, which is equal to 1, 2. That means the first element, first row, second column. That's why the output is 2. So that's what called as the row and the column. Row and the column. Row and the column. Operator 1, 10. So that means here also colon you kept once only one colon is there. That means left one is a smaller limit and next one is the larger limit. So how many steps it will go? It will go with only 1 step. That's why 1, next step is 2, next step is 3, 4. So like this way you can get a each time one step. 1 step, 1 step, then you can put one more step, then one more step, then one more step. So let us say you put now 2, that means 2 steps. Now you can see here I have 1 to 2 is 1 step and 2 to 3 is 2 steps. So 2 steps means directly to 1 go to 3. So then 3 will go to 5. 5 to sorry, it is 7. Then 7 to 8. You go to the 8. So then 10 is a maximum limit, but it won't take the 10. Go to the like that's how we can give the number of steps. Operator and the matrices. A 3, 2, 3. So that means A third row 2, 3. That means the second column to third column. So how much gap? Gap is only 1 or the step is only 1. So this is my row, these my columns. So my row is third row in this column 2. So column 2 is this one, column 3. So that's why it will be only this one. So only I can take 1, 7, 1, 7. Say 1, 7 and 1, 7. So only we can get a 1, 7, 1, 7. So A. So in the row you can see only colon is there. So that means all the rows will be considered. And 2 is the column. So column is a second column. So here you can see. So all the rows, and column wise only 2. So that means only to take 2, 1, 2, 1. So only this is the output. Like this how the matrix will be. So if you put, what will happen? If A colon, then obviously everything will come. All the elements will come. Then manipulating the matrix. So that means what are the various matrix operations? So transpose of the matrix. We can use A power. So this will be like a transpose. B star A, that means matrix multiplication. B dot star A. So then element by element multiplication. B backward slash, that means the matrix division. Dot A, then element by element division. B A, that means that it is joining the matrices horizontally. So then B semicolon A. So then join the matrix in the vertical direction. So that means we can create another matrix, maybe C or whatever. We can create one more matrix. Join that matrix. So format short, the fixed point with a 4 decimal point. This is a normal or without a default is this one. Division, if you do any operation, normal divisions and multiplication will come like this. And format long E is a 14 decimal digits will be there. Again, the format short E, then here with a 4 decimal digits. This is a format short E. E if you put means, then obviously it will come like a exponential. E means again it will come like this way. And format G, G means a floating point. Normally the floating point means digits. Digit with it will round off this one only with that. And long E means where it will round off here. So the 5 will be there, as well as here, say 1. So 2 decimal digits. Format bank. Format bank if you keep, that means that it is only 2 decimal digits. And format compare. The eliminates the empty lines to allow more lines with the information displayed on the screen. And format loose, so adds a empty lines opposite of the. So then round off we can do like round X. So where it will round like a 20 by 6. Yeah, obviously there is a 3.3 something it will come. So it is less than 0.5. So obviously it will go to the 3. So 13 by 6. So 2 point something. Then let's say you put like a more than 5, then it will go to the next line, next point. So you can see 13 by 5. Actually 2.5 it crossed. So obviously it will go to a 3. So then REM returns the remainder after X is divided by Y. The floor X round towards minus infinity. So sin X comma Y, then sin 7. Then various other function SQRT, square root, log, log, COS cos, A cos, sin, A sin, like same with tan, cosine, A tan, cot, A cot, cosine, all the things will be there. EXP is nothing but an exponential. ABS is the absolute. SIGN is the sign. NORM is the normal. And some PROD is the product. And this is about the plotting. Next we'll move to the next one is called the plotting. Plot these diagrams. These plots we can go with a two-dimensional plot or the 3-dimensional plots. So normally this plot versus time. This plotting time comma distance. The plot one vector to another vector normally. Let's say the first one will be treated as an abscissor. Time will be treated as abscissor, and or the vector, and the second as the ordinate. Y as the ordinate. So the vectors have to be the same length. Normally it should be the same length. Then only it will come as a plotting. Time comma distance. So we can add some plotting time, or we can make these modifications here itself. And plotting versus index. So in this case, this as a dist, and then dist as a distance, and then y it will take it as a normal numbers. And we can use some lines, line styles, line characteristics also we can use. Then plot, we can hold it, and we can split to the several axes, and that is called the subplot. Then rows, columns, and place, where to place this. So there is a annotation. Annotation means giving the labeling, X label, Y label, then what the title for. And the legend means any distinct function in the graph or something. If you want to write something, then it's called. So we can take one example here, where X equal to line space 0, 4, 500. So 22 by 7 by pi value. So this normally will represent with the pi. Here we can see here is the pi. Is a pi we can see here. So this is a line space x, then sine x, plot y. So then we can plot like this way. Plot y, either you, like you can get a plot in this manner. So where we are given as a till 100 with the x, then plot y. It will be like this. This is the line space, and this is a plot. Is it clear, all of you? Would you like to practice, or? Please wait for 1 minute. Let them practice. So then we'll move to the next. For example, create an X array of 100 samples between 0 and 4 pi. So here it is like a minimum limit is 0 and maximum limit is 4 pi. In between there should be 100 points. Then plot y1. So y3 exponential x by 3 plot. Then create an X array of 100 samples between 0 and 4 pi. Then x is a line space, and then y sin x, y1 which is equal to exponential minus x by 3, y4, y star dot star y1, and plot y4, stem y4. So now you can see here, these plot y4. We have plotted this one, and stem. So now we can get a like a stem kind of thing. This is about the stem. Stem y4. Hello. Gupta sir.
Yeah, sir. Yeah, please tell me, sir.
So
This is Nagaraj.
they are asking like, can you give them some permission to talk so that they can ask some doubts?
Okay, sir. To whom I should give, sir?
Vinod Kumar. Vinod Kumar.
Participants can unmute themselves.
Yeah.
Then it will be easy for them.
Ask unmute.
I was called to unmute, yeah.
Yes, sir. I've done.
Good afternoon, sir.
Good afternoon.
Sir, in the previous slides, to get the matrices like from third row, second column and third column elements, can you go to that slide, sir?
So is it?
Here, sir, here. So here, what happen if you type a colon? So here we will get the complete all 3 rows and 3 columns, right, sir?
Yes. You will get the all three rows. I mean, complete matrix will come.
Complete matrix. Okay, sir. This is only doubt, sir. Thank you, sir.
So here the create an X array of 100 samples between 0, 45. Already we have seen actually in the previous case we are not having any grid. So now we are grid on. Plot Y4, the same thing here. We got the plot Y4. So once you on the grid on, so we can get the grid. So backside there is a grid. Able to see when compared with this one, this is a flat, and this here we have some grids. So we have some grid here. So then with these are the basic understanding, then we are moving towards the control conditions, or the also called as the loops. So here the two types of loops will be there. One is a conditional statements, and another one is a infinite loops. So where the conditional loops, where it will check this condition. Condition is nothing but an expression, and once this condition is true, then whatever the statements which are related to these will be executed. So this is called the expression. Then if the statement, and if this condition is, that means the expression is not true, then these statements won't be executed. So then it will come like this way. So first you can see here the expression. This expression is true, then it will go and execute this statement. So that means here the true condition. If let us say the condition is false, so then in this case it will go to the elif. Then it will check this condition. If this condition is true, then it will go here. If not, then it will go to the next else. Else there is no checking and all. So directly it will go here, and after that it will execute this statement. And end means it will come out of the loop. So like this way, the else there is no conditions will be there. Here there are no expression, no checking. So if both the conditions are not true, then obviously it will go to the else. Like this way, maybe you can put like some x equal to bigger number, smaller number checking. So maybe a given number is a less than 10. Then go to okay, you print less than 10. Let us say from 11 to 20, then you print, so it is in between 11 to 20, or else above 100, sorry, above 20. So like this way you can put, or otherwise even number, odd number. Like if division with division which is equal to 0, then it is called the even number. If division is not equal to 0, then it is called odd number. If both are not, then obviously is a non-even, non-even, not odd. So like that way you can put like this. So these are these if else. So elif here we can use n number of elif commands. So we can use the n number of elif commands we can use here. So here only one condition I kept, like let us say you want some more conditions, like 7 conditions, 8 conditions. In that case, only let us say 8 conditions, only 2 conditions with if and else. Then remaining 6 conditions you can put it the elif like this. Then next one is called the switch case. Switch case is the one special sort of the command which is normally used in the flowcharts. So where it will switch some switch experiment, then it will go to this case. It will check with this case, it's fine, then these statements will be okay. Otherwise, it will go to this case. So if all the cases are not being true, then in that case it will go to these otherwise, and it will execute these statements. So like this way, the particular statements should be executed. Then in that case, we can use switch case. It will switch to the different cases. In the same thing we can did for the if also, but whereas the switch case will work like it is not related with each condition is not related with each other. Like if once you put a one if it is not, then else will come. So here it is related with each other. But whereas switch case, if it is not related case, then we can go for the switch case. Then flow control loops. So here there is 2 types of loops are there. If you know definite number of iterations, then we'll go for the for loop. But if you don't know how many number of iterations, then in that case while loop is there. It's called definite loops and indefinite loops. Go with this. So for loop we can say ind, which is 100. So here we can clearly understand 1 colon only one colon is there. So that means the steps are not there. So each one time it will go. So 1, 2, 3, 4 like this. One step it will go. So that means we have 100 numbers now. So we know it exactly. So alternatively, most of loops like x 0.1, 0.1, 10. So here also we'll have a almost like 100 will have. Then while looping. So here you see the while x is less than or equal to 10. Till these x is less than or equal to 10 only, till this condition true, then we'll give. So let us say I give this x which is equal to some matrix 1, 2, 3, 4, 5, 6, 7, 8. Then what does it do? It will keep going on. Take x is less than or equal to 8, or otherwise I'll put x equal to some 7. Then I have this loop. Maybe the x is less than 7. That's what my print. Then it keep going on. So when will it end? It won't end. It keep on going on. So because this condition has to be satisfied. So here due to this indefinite one, like the same thing with the for loop, then x cannot be like a x is less than or equal to 10. Condition cannot be given in the for loop. We can give only the what is x. That's all. So like this, how that is the difference. If while loop, normally it can go with a infinite loop also. If you just do a little mistake while you are assigning certain values to these, if you perform or if you give a overlook some wrong command, then the loop will continuously runs. It won't be stopped. So that is the problem with the while loop. That's why it is called as the indefinite loop, where the for loop is a definite loop. Then there is a M files. So now we'll come to the script file. We have checked some line where whether it is working or not, assigned certain value and got the output. But let us say I have some 7 or 8, 10 lines command is there. After this execution only we need to get it. So then in that case, and also I want to modify that code again. So I want to use these as a some continuous one, whereas command window, whatever I am writing, it will get the printout, and if you once you press a C, it will go. So we can't revert back that data. So for these are the two reasons where there is a lengthiness of a code is large. Then one more thing, if you want to modify that one at any time or use that one for the further uses, in that case we'll go for a script file. Those are also called as M files. So the function y, which is equal to fx, and function u comma v, f x comma y comma z. These are the functions where we can start with the function definition like this. These are the functions, and in the same way, these are the things where we can link one file to another file. We can link one file to the another file. So the end of this total file will be executed in the another file. So in that case also we can use like function. These what are the variables inside the major one, and these are the in the present file, present one, what are these? So these about the u comma v belongs to the file variables which are being used in a file called now at present file. This present file called present file is a function u comma v we are using here, and f is a that file particular whatever we are going or we are using. So this is called f x comma y comma z are the variables related to that. Like this way, the file name and the name of the function, the file are used identical. However, while they are different, Matlab use the file name to call the function. So this function will be called. So this function will be called. So if you add additional function in the same M file, it consider the sub function. So this will become a sub function and might be called from the inside M file only. So for this case also, if you want to use one file in another file, so then that case also will use the M files. So the saving results, how we can save this one. Say we can save, maybe you can give some file name, then which directory to normally ask where you are keeping this one. This is a file name called txt. It will name as a only the notepad, but whereas .m file, so it will save as a mat. So even we can save in the ASCII format also, .mat or nothing but .m file. So these are the file formats are available. And now we'll check with some problems, some access problems we'll see. Here the some vibration related problems also we'll see. And after the few problems, then we'll go for the polynomials, and after that we'll go for the vibration problems. So create an X array, 100 samples between 0 and 4 pi. Already we have seen y1 sin t, y2 equal to t. So y3 which is equal to t minus t3 by 3. So plus t5 by 5. Then 5 this factorial, then plus t7 by 7 factorial, then the plot command, hold command, the line command. So the same thing will evaluate by using this plot command, hold command, and line command. And next, use the function for plotting x comma y data for plotting the following functions: ft, which is equal to t cos t, and where the t limits are given, and x e power t, and y 10 plus e power 3t. Then this is the first one. So this is the editor file. This is the editor file. This problem one, I have divided these all the problems into different. Are you able to see this one? Hello. So T line space. Because all the progress I combine into only one plot. That's why I'm selecting this one and right click, evaluate selection. Like this way I can use this. So here you can see line space 0, 2, 5, 100. So 100 divisions we need, but my minimal limit is 0 and maximum limit is 2, 5. So y1 which is equal to sin t, y2 which is equal to t, y3 t minus t whole cube by 6 plus t whole to the power of 5 by 120 minus t whole to the power of 7 by 5, 0, 40. So these are we are considered from the problem, not we are not taken by ourselves. So y sin t, y2 which is equal to t, and create an array. It is 4 pi. Actually, I have taken this as a 2 pi. It's a 4 pi. And y3 values. Then this is a command called plot command. So plot, what I need to plot t comma y1, t comma y2. So these with a one line. This is my plot. So you can see the color here. T3 comma y3 with O. So these O are there. They are all related with the y3. So here sin t, the plot versus sin t y1, where t is nothing but the y2. T comma y2. That's why this is this line, and x label equal to t, and y label you can see here, y label sin t approximation. Sin t approximation is the y label. Then text 3 comma 5, 0. So these are the limits. It's called the sin t values. Then g text linear approximation, g text 4 term approximations. So these are not the labels. The sin t is appearing here. Then same thing with a hold command. Hold, you can use here hold 0 to 500, then hold down, then plot y2, because here I plotted everything in the one time, but here y2 I plotted y2 which is equal to x, plot x comma y2, and then maybe now you can like you can see like, otherwise you can put like a the special characters are not like you can use it like So this is came as a star. You can check here. It came like a star. So y2 has become my star. And then anyway y3 having a called O with O style. Then y1 I have not given anything. Maybe we give some other thing with the y1, then obviously that y1 also will come as a different style. So then hold off here, because hold on. I started with, because I plotted one y1 and then after that I got to hold on. Otherwise y1 will go, then y2 will come. Then y2 will go, y3 will come, because I am plotting y3. So like this how it will happen. You can see one more thing here, semicolon, after that plot. So then the plot and these two are used at a one place. Sorry, with a one line. Then same thing with a line command. Line command. You got the, now here X label, Y label, title we have given. So here it is called a legend. Legend sin t, linear approximate, 7th order approximation. So each one we have given differently. Then if you want some separation, maybe you can give here some other separation, like previously we have given, like star or something like this. You give this mark and then you line modify. One of these line styles are given only this one.
Sir, PPT is not changing, sir. It is in 37 page only.
No, you could not see the program.
No, sir. No, sir. 37 page only. It is there, sir. Still that.
No, I am working on the program.
Okay, okay. Not able to see, sir. Now it is okay, sir.
This one I can give like this way. So you can see now these are the 3 lines. We have given the legend also here. That legend means it will give the title. So this is the legend. So this is what called as the legend. Then a line space. This is called a plot. The plot is this one. Then line space, log space also. Log, it is a grid one. There is a grid, it will come as a grid. Then we can plot x comma y. So like this how we can use various way of solving it. This is what program 1. These programs are available. That's what I run now. So then we can see the next one called the problem 2. Obtain the mesh and surface plot of the function z is equal to 2xy square by x square plus y square. X is having a limits and sorry, y is having the limits. This is y limit. These are. called y. Can you able to see this one PPT without presentation mode? Hello.
Yes, sir. Yes, sir. We can able to see, sir.
Now we can see this problem too. So x minus 2 to 6 and limit is 0.1, then 2.18, then x comma y mesh grid, and then z value mesh x comma y comma z. All the 3 dimensions are the 3 we need to do here. The x label is called x-axis, y label is y-axis, z label is z-axis. Surf. So unless we give this surf, the surface won't come at 3 dimension. Then these are the x labels. So that's what this z is having. Y-axis 2 to 8, then minus 2 to 6. Z is a multiplication. According to this multiplication, the values will be obtained and mesh. So here legend won't work here. Yes, already it is a 3D space. There is no legend is possible here. So you can identify any one particular point also. What these coordinates, that is also possible here. Can you able to check here? You can check at any place. What are the, so here it won't show, but whereas the coordinates of this particular 3D surface will be given. So like this, how we can be able to print some 3D commands also, or the 3D graphs also. Then we'll take these polynomials with equations. Any equation can be solved by using the Matlab. For this, I have taken a variable called pol is my variable. I have taken my y1. You can take your own variable. Like here, I have the x cube plus 2x minus 7 is my equation. So for this equation, I need not to give the equation. Just pol, which is equal to some variable, and assign 3. 2 will be 0, and x will be 2, and constant will be minus 7. Then you can get the pole roots. If you solve these roots of this pole, then obviously it will find all its roots. Then same way, poly roots pole. So we can make this as a poly. Poly means reconstruct this one. So this will be displayed in the form of a scalars. Before it is like a vector, but whereas here now it is displaying like a scalar. So that is the thing, we can do it. Yes, this is a polynomial where here one equation x to the power of 4 minus 8x plus 120 equal to 0. So then roots, here you can see the roots. Only execute these roots, that's all. We got the solution called like this. These roots came. Like this way, any equation. Like minus x to the power of 4 here, let us say x to the power of 3 or 2x. So then you check now. Now for this root also we can able to find. So this root also. So like this way, any roots can be found.
So, Dr. Ramesh, sir, your screen is not visible, sir. We can't able to see your screen.
Now, hello. Can you able to see now?
Sir, Matlab is visible, sir. Matlab is visible.
Yes, I
Yeah,
am
no,
using only
yeah,
the
now it's,
MATLAB script file.
Yes, sir.
yeah, now it is okay, sir. Yeah.
So then these one where we can use this matrix and then matrix addition, matrix multiplication, matrix power, then transpose, inverse, and then B transpose, multiplication with A transpose, then A power 2 plus B power 2 minus A plus B, det A, det B, that det means determinant, where I addition multiplication of these matrices. So all these combinations can be possible here. You can able to see now result. So these are the various results. Here I have not asked for the A plus B, I am not asking result. Then only det A, det B, det A multiplication with B. So I only these 4 results are there. That's why only these 4 results. Like this, these multiplications can be done very easily. Then already we have seen the polynomials. So then here eigenvalues and the eigenvector, how we can find. So A having a matrix, the natural frequency matrix 2, minus 1, minus 1, 2. Then so eigenvector, eigenvalues. Like this, how we can find out with EIG. Then this is related with one question. Now we take a one vibration problem. An analytical expression for the response of an undamped single degree of freedom system shown below. Can you able to see this PPT? Hello, all of you. Able to see the PPT?
Yes, sir.
Okay. An analytical expression for the response of an damped single degree of freedom system shown below to give an initial displacement and a velocity xt c e power minus zeta omega nt cos omega dt minus 5, where c and f represent the amplitude and phase angle of the response, respectively having the values, where this c value and phi value and omega d value, these about the particular system. So these are problem, and I given the values for this. Omega and natural frequency is 5 radians per second, zeta which is equal to 0.05, zeta 0.05, 0.1, 0.2. The subject to an initial condition x equal to 0, x naught is also v naught, both are equal to 60 centimeter. That means the initial value, initial displacement and initial velocity are 60 centimeter. So then solve these one, because already these equations are available to us. Only these values we have to substitute in these equations. That is the solution. Very simple. It's called Y1. We'll check this one now. Only substitution. So clear all CLC or CLF, no problem. Omega n already we have took from here. Natural frequency, omega n, zeta values. So zeta 0.5, 0.1, 0.2. So I take this as a matrix. Then column matrix. So x naught which is equal to 0, that is initial displacement. V naught initial velocity 60. 60 centimeter, 6 centimeter or 60 millimeter I have taken. So normally it will take the 60 centimeter. Actually I have taken the same thing. Normally it will take as a meters, I think. So t initial time is equal to 0, delta which is equal to 0.01, then tf the final time step is equal to 0.01, and final time is equal to initial time 0 and final time is equal to 6. So t which is equal to t naught delta t tf. Otherwise same thing, same values also we can give. We can reduce the number of lines, that is also possible. For I1 length zeta, so how much length? So I have to substitute I is nothing but my zeta value. So omega d square root of 1 minus zeta square multiplied with omega n. This one omega d is equal to root of 1 minus zeta square into omega n. So that's what I have given here. 1 minus multiplied with, so you see here square root is applicable to only this one, then multiplication with omega n, then x. What is this x now? X equal to this c e power minus zeta omega nt cos omega dt minus 5. So exponential minus zeta I omega nt zeta I omega n x naught plus v naught by omega d sin omega dt plus x naught cos omega dt. Then plot t comma x. Hold on, we have to hold on because these a zeta is having 3 values. So those 3 values has to be there. And response title will be response to the initial excitations. X label is TS, Y label is XT. Grid, we have to put a grid, and legend XT TS. That means legend will come. So like this, how we'll get the XT TS. For 3 different values. 3 different values we got. Is it clear, all of you? Then we can take one more example for the multi-degree freedom system. For systems with arbitrary viscous damping, the response must be obtained in the state space, which implies the use of the transition matrix. If the response is to be evaluated on a computer, then the state equations must be transformed to discrete time, determine the free vibration response of a 2 degree of freedom system, then initial one values, and this is the force acted. So mass matrix is this, K matrix is this. We need to find out the forced vibration response using the Matlab program. So where F naught which is equal to 60. Wipe 2. So M is equal to 25, K is equal to this one. I given the mass matrix, K matrix, Z inverse, eigen values and the eigen vectors, then J 1 to 4, then I 1 comma 4, 1 to 4, then forces, Ft responses, so once the programs are larger, it will take some time. Like this, how we can get a solution. So just before going to close, this is the book, solving vibration analysis problems using the Matlab. those who want to work in the vibration problems with the Matlab, please, these available online. Please follow this book. And a lot many varieties of problems are there. You can solve it, and some maybe some printing mistakes also there that you can rectify by yourself. So that's what from my side. Thank you all of you. And these my contact mail ID from the VIT, Vellore Institute of Technology, Vellore. In tomorrow's session, we will discuss about the composites, how we can use the Matlab programs, and some vibration related and the combination we can discuss. So any doubts, you can please raise.
Participants can ask the doubts in the chat window, or I'm just unmuting you. You can unmute yourself and you can ask the doubts. Hello? I'm audible? Hello? So since it is an hands-on session, I think, sir, there are no doubts. Prasanna, sir, you have any doubts? Hello, Ramesh, sir?
Yes, madam.
I think because it's a hands-on session, people are
Okay.
practicing. Yeah.
Yeah, no issue,
Yes,
no
sir.
issue, madam.
So,
So shall we wind up, madam?
yes, sir, with your permission.
Definitely, madam. Sure.
So thank you very much, sir, for the wonderful